Hello again. We are moving on in our discussion of polynomials, and we're going to talk about asymptotes. This is 11.4, so let's get started. First, we're going to talk about a vertical asymptote. What that is a vertical line on the xy plane that the function will not cross. They exist for any x's that make the denominator 0, but not the numerator. Okay, that's a different situation when an x makes the numerator and the denominator 0. We're just looking for the ones that make the denominator 0 only. Okay, so for example, I've got 6 over x minus 4 plus 7. Okay, so I have a vertical asymptote at x equals 4. Another example, I've got x plus 1 times x minus 5 all over x plus 9. There's a vertical asymptote at x equals negative 9. The third example, I've got x minus 2 times x minus 3 all over x minus 3. Even though 3 makes the denominator 0, it also makes the numerator 0. So there is no vertical asymptote there because 3 makes the numerator and the denominator both equal 0. Okay. Now let's talk about horizontal asymptotes. I want you to understand that even though a vertical asymptote, the function will never cross a vertical asymptote, it is okay for the function to cross a horizontal asymptote. The only thing a horizontal asymptote is going to tell you is end behavior. So it's going to tell you, it's going to give you like a boundary line for what's going to happen to the y's as x gets really, really positive or really, really negative. So that's what it tells you. So if anyone says you can't cross a horizontal asymptote, that's not necessarily true. Some functions don't cross it, but some functions do. All it tells you is end behavior. So to figure out what the horizontal asymptote actually is, if the degree of the numerator is less than the degree of the denominator, then this function will have a horizontal asymptote of y equals 0. If the degree of the numerator is bigger than the degree of the denominator, then there is no horizontal asymptote. It could be a slant asymptote, it could be a parabolic asymptote, it could be worse, but we're only dealing with horizontal asymptotes here. So you don't have them when the degree on top is higher than the degree on the bottom. If the degrees are equal, so the degree on top is equal to the degree on the bottom, what you do is you take the lead coefficients on the top and the bottom and you make a ratio out of them. You make a fraction out of them, and that fraction will be the y coordinate of the horizontal asymptote. So let's go through some examples of these. For example, if I have y equals x minus 2 over x squared plus 5, on the top I have a degree of 1 because the highest exponent of x is 1. I've got an x to the 1 there. On the bottom, the highest exponent of x is 2, so the degree of the bottom is 2. So this is one of those situations where the degree on the top is smaller than the degree on the bottom. And what we said in that case was that the horizontal asymptote would be y equals 0. In the second example, I have a degree of 3 on the top because I have an x cubed. I have a degree of 1 on the bottom because all I have is an x to the 1. So the degree on top is now higher than the degree on the bottom, so I do not have a horizontal asymptote. I could have something worse, but we're not dealing with that. And in the last example, I have a degree of 1 on the top because the highest exponent of x is that 3 times x to the 1, and I also have a degree of 1 on the bottom. So the degrees are equal. So what I do is I look at the lead coefficients on top and bottom. The lead coefficient on top is the 3 because it's standing in front of the highest exponent of x. The degree on the bottom is that 4 because it's standing in front of the highest exponent of x. So the lead coefficients are 3 and 4, and if I make a fraction out of those, then it's 3/4. So the horizontal asymptote in this case will be 3/4. Now that's if you have purely fractional functions. What happens if I turn around and I add some constant to that function? Well, based on what we learned before, that whole function is going to shift up 9 spaces, and that's going to affect where the horizontal asymptote is because the horizontal asymptote is going to move right on up with the rest of the function. So the horizontal asymptote is not 0 anymore, now it's 9. If I did the same thing with the second example and I added a random 5 to that exponent or to that function, I'm still not going to have a horizontal asymptote, so I'm still not worried about it. And then in the last one, when I add 7, then that horizontal asymptote of y equals 3/4, that's going to move up 7 spaces along with the rest of the graph. So now the horizontal asymptote is going to be at 7 3/4. So that is a brief look at asymptotes, both vertical and horizontal. We're not going to worry ourselves with any other kind of asymptote in this course. So if you have any questions about those, please let me know, and I will see you tomorrow.